I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider the angles formed by tangents and secants and arcs. Before getting into some questions, we'll also look into proof of theorems based on which we are going to solve the questions. So, one of them is the measurement of chord angles, the other one, the angles formed when secants are drawn. And here are 10 questions which we are going to look into. You can pause the video, answer these questions, and then look into my suggestions. So these are the questions which we are going to answer in this particular video. They involve intersection of chords or intersection of secants and tangents. Perfect. Some of them you may have to find the value of x here and then calculate the angle and the arc lengths. So those are the 10 questions which need to be answered. Before answering these, let us understand the concept. We are given a circle here with two chords, the chord AB and the chord CD. They intersect at a point in the center somewhere inside the circle. We need to find the measurement of angle 1. So how is this angle 1 related? That is what we need to find. The formula is that this angle is average of the sum of angles subtended on the two sides. So we know that this angle 1, we say the measurement of angle 1 is equal to the average value of measurement of these two arcs, which are arc AC and the measurement of the arc BD. So that's the formula known to you. You can always apply this formula, get the result. But it is a good idea to understand its proof also. So let us look into the proof first. We know this angle 1 is external angle, right? So in any triangle, external angle is sum of two interior angles. And therefore, we can say angle 1 is angle 2 plus angle 3, since angle 1 is an exterior angle. And each angle is measured in terms of the arc length itself. So angle 2 is equal to which arc? Well, if you look from the angle 2 side, then the arc which it represents is BD. So angle 2 is half of BD, right? So we write measurement of angle 2 is half of BD. Now if you see from the other angle, which is angle 3 for you, what do you notice? Well, angle 3 is half of AC, right? So angle 3 is half of AC. And clearly, angle 1 will be sum of both. So we get this as half of BD plus half of AC, taking half common, we get the average value of the arcs subtended by these two chords. And therefore, we can write down the measure of the angle formed by two chords that intersect inside the circle. As you can see, inside the circle is equal to half of the measure of intercepted arcs. So the intercepted arcs are AC and BD. Add them, divide by 2 to get the value of 1. You get the idea. So one type of questions where you have chords intersecting, you can find the angle using this particular formula. Clear? Now let's look into the second case, which involves a point external. So if I draw two secants, AC and AE, in that case, if I want to find what the angle is at A, I can actually interpret it in terms of the arcs form, right? Intercepted arcs once again. And the formula this time is the difference of arcs, right? How do we prove that? Well, the concept is similar. So we construct a line CD connecting C and D, and now you can see 3 is an external angle. So this time, this angle 3 is external angle. It should be equal to sum of angle 1 and 2. Therefore, we'll begin with angle 3 equals to the measurement of angle 1 plus measurement of angle 2. But what we want is angle 1 outside at A. Angle 1 is the difference of angle 3 and 2. Now each angle here can be represented with the help of the arc, right? So, as we can see, angle 3 is half of the arc CE and 2 is half the arc BD. And substituting these, we get our formula. Is that clear to you? So now I can summarize that the angles formed by the secant lines can be actually measured in this way. The measure of the angle formed by two secants, or also you could have two tangents or a secant and a tangent combination, drawn from a point outside a circle is equal to half the difference of the measure of intercepted arcs. Easy to remember, and now you have a proof so you can visualize, and that should help you to answer these questions quickly. Well, question 1 here is from the review of what you did earlier, right? So, can you answer this question? We are given this angle as 57, but this time we want the measure of major arc, right? Not the minor arc, correct? You know the angle corresponds to half the thing, correct? So, you know, the minor arc, RS, will be how much? It will be twice the angle, and this will be 360 minus twice that angle, correct? So you can answer the first question as this here will be 2 times 57 degrees, correct? And therefore, the arc in question, which you're writing as question mark, will be what? 360 degrees. Take away 2 times 57 degrees, correct? So that is how you could answer this question. Now, if you remember, alternate interior angle, that could also be applied. So let us relate to our learnings. So if I construct, let us say we take any point here, right? So let me just take a point here and then join that point with these two, right? In that case, this angle will be how much? Well, this angle will be also 57 degrees, right? This is an alternate segment, right? And from there also we figure out that this arc will be twice the angle and the other thing will be 180 minus twice 57. Is that clear to you? So we can write this answer as 360 degrees minus 4 and 10 and 1, 11. And so that gives us the answer 360 minus 114, and that is equal to how much? 10 take away 4 is 6, and then 5 take away 1 is 4, and 2 is 246 degrees. Is that clear to you? So that is how you can easily find the solution. Now let's see the next question. It is kind of reverse. I think you can get this. This time you have to find the angle. You are given the arc, correct? So the length arc angle, it is half of it. So measurement of this angle is, this is the angle we are trying to find, is equal to 144 degrees divided by 2, correct? So it is 72 degrees. Question number 3. So clearly this angle is half of 90, so that has to be 45 degrees. Question number 4. So take a moment and try to answer this question. What should be the value of this? Let it be x. So pause the video, answer the question. Now since these are the chords, it is the average value of the two intercepted arcs. So x is basically equal to half of 55 degrees plus 195 degrees, which is half of, so 5 and 5, 10, and then we have 10 and 5, 15, 250 degrees. That gives you 125 degrees as a measure of the given angle. You get the idea. That is how we have to solve these questions. So these are the practice questions. I will solve one more for you. This time we have two secants, right? It's outside point T. You need to find the measurement of the major arc V to C, right? This is what you need to find. Now that should be the difference, correct? So we can now write down our formula that this angle 55 degrees is equal to half the difference. Let's say this is x. So it is x minus 45 degrees, right? 45 degrees is this arc length, minor arc length. So we'll write 45 degrees here, and now we can cross multiply. So 2 times 55 degrees should be equal to x minus 45 degrees, which is 110 degrees equals to x minus 45 degrees, and 110 plus 45 degrees, right? So these are all in degrees, is equal to x, and clearly it is 155 degrees. So that is how we can actually solve this particular question. Now I hope that you have understood the concept, and so you should try to answer these questions. Now here we are similar to what we had done earlier. You need to find the unknown arc, which in this case is this, and the angle, right? These are the two things you have to find from the given information. Since it is inside, I'll definitely write down the equation for you, which clearly is that this angle 32x minus 1 should be equal to half the sum of these two, which is 16x plus 1 plus 189 degrees, correct? So that is how you have to write the equation and then solve it. Next question, question number 7. Now we have the chords, and you know this value of the angle is the average of the two intercepted arcs, and therefore the equation will be 16x plus 6 is equal to half the value of 15x plus 5 plus the 75 degrees, correct? Solve and get your answer. Now, in case you really want to learn from me, you can always send an email on the address given, right? Here are more questions. These questions are similar. This is similar to the very first question which we answered. You can write down the equation and solve. Next question is also where this time we have a secant and the tangent, right? So secant tangent combination, however, you have to still look into these two arcs to answer the question. The last question here is similar to the previous one, was secant and tangent example. Perfect. So I hope that makes sense. You can always write to me on the email address given to understand the concepts. So once again, it is important to understand how do we get the formula which is being applied so many times to find the unknown values. We have looked into two cases, intersection of chords which forms angles and the arcs, and then the intersection of secants. So I hope with this the concept is absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.